Hello everyone and welcome to my YouTube channel. This is part 5 of competition days and 30 days of machine learning by Kaggle, and today we are going to learn about blending. So blending is probably going to help you a lot in this competition because the data seems to be designed in that way and there's not much you can do when it comes to feature engineering or feature selection. So you learned about the K folds, we divided the data into folds, and that was the first step we did. And we saved a special file called train_folds. Now we will know why we did it that way. So let's say this is your data set. These are your samples. So sample 1, sample 2, sample 3, and so on, or the number of rows in the data set. And now what we did was to divide this data set into 5 equal parts. So we took k equal to 5. You can also take k equal to 10. That's also fine. We divided into 5 equal parts. And in each part, we have like some number of samples. It's more or less the same in each of them, the number of samples. So let's call this one fold 0. This is fold 1. This is fold 2, 3, and 4. And now whenever we are training a model, so if we have a model, let's say XGBoost, and we are training it on, when we are saying that it's on fold 0, so our validation fold is 0. So we take 0 as validation and we take everything else as training. And our training fold is 1, 2, 3, 4. So why are we looking at that? We should just look at blending, right? Blending is, you will understand blending only if you understand the K folds first. And then we made a function. So we had a function, run function, let's say, that takes a fold number. We didn't make this function, this exact function, but we can do it this way. That takes a fold number and then returns you the predictions, return predictions on test set, and it can also return you the predictions on validation set, valid preds, or preds_valid. So when you're training your model on 1, 2, 3, and 4, you're evaluating on this 0. What you can also do is when you're evaluating, you are already making some predictions. So you make predictions 0, and you have the test predictions. Let's call it test 0. Similarly, you have preds 1, test 1, preds 2, test 2, and so on till 5. We can average these and call these test preds. Given a model and the k-fold data that you have created test preds by taking mean of the predictions from each fold. And this is what we have been submitting to the competition at the moment. But we also have this, and we have been ignoring it. So pred 0 is the prediction for 0th fold. And then you have preds 1, so let's call it P1, P2, P3, and P4. Okay. So when we have all these and all these, so when we have all the valid predictions, we are actually making a new set. We are making a new training set. So let's say my model 1, some model, it can be XGBoost, LightGBM, CatBoost, linear regression, whatever. It generates a list of predictions in the same order as the actual training data. So this is your valid predictions and your test predictions, which is mean from each fold. Test predictions. Okay, let's call it V1 and let's call it T1, and this comes from M1. There can be another model M2 that gives you V2 and T2. There can be another model that gives you V3 and T3. So you're getting the idea now. You're making different models and you're generating predictions on the validation fold for the whole training data. So if you're training on 1, 2, 3, 4, generating on 0, you have 20% of the data validation predictions, and it's not overfitting. So the idea is to keep the folds consistent. So if you have trained M1 on some folds, you train M2 on the same folds, and that's why we split the data and saved it in a CSV file in the very beginning. M3, we train on the same folds. So now you got a new data set, and this becomes our new training set. So new training set has V1, V2, V3, V4, and so on. As many models as you want. The only thing that you need to take care of that the IDs of this must align with the original IDs. They should always align together. And that's how you can add the same old target column here. And for test data, you have the same thing. You have T1, T2, T3, T4, and target. Sorry, you don't have the target for test data. So you have T1, T2, T3, T4, and so on. So now what you can do is you can find out how these different predictions will combine to generate the target for test data. So what we do is we assign weights. So we say like our prediction is nothing but W1, V1, W2, V2, W3, V3, and so on. So now your task is to find these weights and use the same weights with T1, T2, T3, T4, whatever, to generate the target for the test data. A very simple way would be to just take an average. So that's also blending. So if you have two models and the weights are 0.5, 0.5, it's a simple average. And this is just a weighted average. And you have to find the weights. That's your task. So how to do it in code? Let's take a look at that. Let me go back to Kaggle notebook. And here we had the part 2 feature engineering. We created a lot of features. One thing about blending is you must keep the folds consistent across all models. And your data should align with your predictions would align with the IDs in training set or with the targets in the training set. So that's the only thing that you need to take care of. But you can use any kind of features you want for training different models. So different models can use different features. They can use different hyperparameters. Doesn't matter. They are different models. So a very simple thing to do would be to just take all this. Let's first create a new kernel. So we are creating a new kernel. I'm taking XGBoost as my base model. It's all old code. We are just going to change a few things. That's it. So let me set this up. I also need to add the data. So I can just search for 30 days and it should show me the data. If it doesn't, then we go to my data set and add the 30 days folds. So now we have added the data. We have run the first cell, and now we go to our feature engineering notebook and see what can we do. We take all this. Let's say we take all this, and we paste it here. Okay, so now this is very simple. So we have XGBoost regressor. We have it running on the GPU so that it's faster for the video. You can run it on CPU if you want. And we have valid predictions. We have test predictions. It's printing the fold scores and printing the mean predictions. Okay, fine, but it needs to save a few things. So final predictions, let's call it final underscore test predictions. And the other one will be final underscore valid predictions. And let's make it a dictionary. We can also make this one a dictionary if you like. Let's make this a dictionary too. Okay, so now this is a dictionary, this is a dictionary. We have the training and validation set. We are copying the test set. Here, we do valid IDs. We want to know what the validation IDs are, and valid IDs will be xvalid.id.values, and we convert it to a list. Okay. Similarly, we have test IDs. I mean, we are not shuffling the test set, so we can skip this and let's keep this as a list. But it's very important to take care of IDs in the training set. And now here we generate our predictions for the valid, predictions for the test, and here final underscore test predictions. There we append the test predictions. So now we have the test predictions appended there, and what we do now is we add values to final valid predictions, which is a dictionary. So to update a dictionary, what you can do, final underscore valid underscore predictions dot update, and this should be a dictionary. So let's create a dictionary by combining the IDs and the predictions from the predictions for the validation data. So we can just do dict, and then there's the method called zip, and here we can write valid underscore IDs, comma, preds underscore valid. So now this has created a dictionary in which the key is validation ID or the training ID, and preds underscore valid is preds comma valid. So here you should look at the training data. You have an ID column. So I'm just trying to match this ID column to the correct prediction. That's it. And it can be done in many different ways. It can be done in better ways, but this is how we are doing it right now. It's much more understandable. Okay, so now you have created the final valid predictions, and now it's the time for saving these predictions somewhere. So it's time for saving the predictions, and we need to save the test predictions. We also need to save the validation predictions. So what we are going to do is we are going to add a new cell. Okay, so final valid predictions, final valid prediction, final test predictions, final test predictions. Am I missing something? Okay, let's run this. And while it's running, we take the final valid predictions and convert it to a data frame. So we just say pd dot data frame dot from dict, since it's from a dictionary, and here we can add final underscore valid underscore predictions, comma orient equal to index. So if you don't understand this, don't worry much about it. Let's take a look. Okay, final valid predictions orient dict. So now you're getting a data frame with an index. You have 1, 8, 13, 14. So these are the IDs, and these are your predictions. And this must be of the same size of the training data. So 300,000 rows. And what we are going to do is we are going to add dot reset underscore index. It will reset the index. So now you have two columns. So original index comes here. That's your IDs. So we rename the columns. So now we rename the column. So I can just take this here, paste it here. So I got a new data frame and final valid prediction dot columns. So my columns will be, the first column is the ID column. Sorry, first is the ID column, and second column is the prediction column. So now it's better if we give it a name. So we can call it target, or we can call it prediction underscore 1. So pred underscore 1, because this is our first model. Okay, we got this. And now we do the same thing. Let's go back. Did we create our submission file here? No, we did not. But I think we did in some of them. Okay, but anyways, so now we don't need to take care of the order of IDs for test data because we are not shuffling the test data anywhere. If you're doing that, you have to do the same for test data. So now we have created our data frame, final valid predictions, and we have also read the sample submission file. So what I'm going to do is I'm just going to write sample submission, and here we always took a mean, if you remember. So I don't see that code anywhere, but it was something like this. So sample submission dot target will be your np dot mean, and here you can take final test predictions. So you have to stack them, np dot column underscore stack final test predictions, and here x is equal to 1. Okay, when you do that, you have your sample underscore submission, which looks something like this, the file that you submit. And you can also change the name of the columns equal to id comma pred underscore 1. So keeping the same name as here. Okay, let's do all this in the same line, and now I can save it. Sample underscore submission dot to CSV. I can save it like test1.csv, let's say, or I can just call it test underscore pred underscore 1.csv and index equal to false. So I'm just saving it as a normal submission file. But now we are also saving this one, final predictions, and this can be called train underscore pred underscore 1.csv. And if we just move everything here, take this one, move it here, so we have everything in one cell. Okay, so now we have everything in one cell, and we just run it, we can save it. So let's just run it, and we didn't change much, right? So it's the same old code. I will take the same code here and I will paste it here, and now we will add some other feature. So let's add some other feature. Which feature should we add? Polynomial features. Okay, let's add the polynomial features. So I'm not even doing any kind of processing right now. Sorry, hyperparameter optimization at the moment. There is no hyperparameter optimization. There is nothing going on. It's very simple. And you can do hyperparameter optimization, because if you don't do that, probably you're not going to get to very good score. So now we do the same thing for another set of features, polynomial features. Maybe I will change something in XGB regressor max depth equal to 2. Something I changed. It's a new model. And let's see, polynomial features. Do we do anything special here? So it's the same old, right? So we don't need to change anything there. And we go back, pred underscore 2. Okay, so we created another model. So let this train. Let's take the same thing again, and let's add something else, or let's remove something else, or let's change the model to light GBM. So there's so many things that you can do. Maybe I can just add the target encoding thing. So I will take all the target encoding stuff from here. I will copy it, and I can put it here. Okay, here goes my target encoding, and it's missing a few things, I think. Yeah, useful features. So we need the useful features. My ordinal encoder stays the same. Okay. I hope you're understanding. If there's any questions, please feel free to ask me, either in the notebook or in YouTube comments. and this will be my predictions underscore 3. So 3, 3, 3, and 3. So I've created 3 models just like that. And all models are different because they probably have different hyperparameters. They have different features. But one thing is consistent. The folds they are trained on and the folds they are generating. So the prediction folds for the training set is the same. We are taking average of test in all of them. And now I have 3 different models. So now since I have 3 different models, what I can do here is I can read these 3 files. So it's 3 submission files. So it's simple. It's 3 submission files, but it's also 3 new training files. So let's say I have to read, so pd.read csv train underscore pred underscore 1 dot csv. So we read this file, I have the ID, I have the prediction. So this is a data frame now. So df1, okay, df2, df3, 2, df3, 2, 3. Okay, so these are our data frames for training, and we have the original data frame. So let's read the original data frame again. Let's read the test data frame, the sample submission. So let's read everything. Okay. So my df equal to train underscore folds.csv, and here I can have df underscore test1. So it also goes the same way. I will just copy paste it. Test underscore pred1, df test2, and df test3. Great. Now what we are going to do, since we have everything that we need in df underscore test1, 2, and 3, and df1, 2, 3, we don't need anything else except we don't have target, which is available only in df. So what we are going to do is we are going to take df and we are going to say df is df.merge df1 on merge on the ID column and merge in left join fashion. Okay, copy paste, copy paste, copy paste. df1, then df2, then df3. Okay, so now if I look at my df, let's see. It looks something like this. So it has all the original features and it also has the prediction from the 3 models. So then see, like, this is what you have to remember. These 3 predictions are in fold 2 and only for ID equal to 2. These 3 predictions are in fold 0 and for ID equal to 1. So you have to be consistent there. If you make any mistakes there, then it's going to be bad. It's going to be very bad. Anyways, so we got our df head and now we will train a model. So we have been training models for so long. I will just copy paste everything from here and I will add it here. And since we are training a new model and our model is very basic, it's like 3 weights, but it is a model, right? And we take all the useful features. One more thing that we need to do here is probably we need to merge the test data too. So our df underscore test equal to take this one, df underscore test dot merge df underscore test1. Take the same thing, copy paste 2, 2, 2, and 3. So now our df test is same as our df train or just df. Okay, now useful features. So what are the useful features now? We don't use all the features. Our useful features for now will be just pred1, pred2, and pred3. So I will say pred underscore 1, pred underscore 2, comma, pred_3. We don't need object columns. Let's see what else we don't need. So we don't need all this. We don't need a XGBoost. Our model is very simple. So preds_valid will be xvalid dot preds_1. Was it pred_1? Pred. So pred_1 plus xvalid dot pred_2 plus xvalid dot pred_3 divided by 3. And we take the same thing and we can make test predictions. So here it was xvalid, now it will be xtest. And again, we have used the same folds. We still have the k-fold column. We have been using the same folds. And when we are testing our weights, which is equal weight 0.333 for each of them, we are testing them in a cross-validated manner. And that's something very important to remember. If you don't do that, you will be in a mess. Okay, and I run it and I get my result. So 0.724. But what I can do is I can also do it in a smart way. So my smart way would be to use a linear regression model. Another smart way can be to convert this to an optimized function which has the weights as parameters w1, w2, w3, and then use Optuna to find the weights. Very good method. So let's say our model, so let me import from sklearn.linear model, import linear regression. Okay. And now it's a simple linear regression model. So it's going to provide me with coefficients. I will do model.fit, xtrain, ytrain, model.predict, xvalid, and xtest. Get it? Simple stuff. And now it's giving me a little bit better score, right? Than just doing 1/3 for all. So I can also print the model coefficients. So if I do model print model.coef underscore, so it gives me the coefficients, like the first prediction matters 0.57, then you multiply by 0.25, 28, 0.25. Okay, all are positive coefficients. So this is one way of doing blending. We used a linear regression model. You can also use an XGBoost if you want. So I'm using XGBoost for blending XGBoost models. Yeah, so this is these are the ways. So let me just use those parameters or GPU so that it's faster and I can show you what's happening. Okay. Sure. Okay, something is wrong. Okay, yeah. Okay, I don't have the .coef underscore anymore. So yeah, it's probably a little bit more better than the previous one. And yeah, that's what it is. This is blending, and in the end, you create the prediction. So I will just use linear regression for now. Much easier to understand. And now in the end, when you create predictions the same way. I will take these sample submission dot target. So here I have final predictions. So I can just do final predictions. Don't need to change the columns anymore, and submission.csv. This one is probably not going to give you a good score because I didn't optimize any models. I didn't do any. I didn't do feature engineering, but I didn't optimize any models. So my models are not very good in the blend, but you can try it. you can have models which you have been fine-tuning for probably a while now. So you can add those models to your blend and see how it performs. And usually it performs quite good. So it's like a voting mechanism. Maybe when you have two models, take the vote of when you have three models, take the vote, and most vote wins. So it's like decision trees, right? Sorry, a random forest in which you have multiple decision trees. Yeah, simple stuff. But all you need to take care of is the folds. So if I have to go over all this again, that's not something I want to do right now. But yeah, I've already told you, create predictions for training set in a cross-validated manner, create predictions for test set by taking average of all those five models if you have five volts, and keep changing the data. Like changing the data, what I mean by that, adding new features, removing features, feature selection, change the model, optimize the hyperparameters, and add 10 or 15 models to the blend. Here we had 3, add 10 or add 15, run a linear regression on it, or you can use Optuna to find the weights. So that will be just like hyperparameter optimization part that you have already seen. And then you probably have a good blend, and you can even get a gold medal in this competition. Oh, I guess there are no medals, but maybe it helps you win a swag. Okay, so that's it for today. I hope you liked the video. If you did like it, do click on the like button, do subscribe, tell your friends about it, and see you tomorrow in the last and final video of this series. Bye.